Ancient astronomers were wrong about why the weather changed. They blamed gods, omens, planetary alignments. Modern AI weather models are also, in a very real sense, wrong about why. They don't understand physics at all, they just recognize patterns in data. And yet both systems worked. Both predicted the future well enough to matter. That contradiction, being right without understanding why you're right, is one of the strangest threads in the history of human problem solving. And it's exactly what we're unpacking today. Imagine you rule a kingdom, and your entire food supply depends on next month's weather. No satellites, no radar, no science of the atmosphere. Just you, the sky, and a decision you cannot afford to get wrong. What would you actually do? This is the problem every civilization has faced since the first seed was planted in the ground. Weather decides when crops grow, when rivers flood, when ships sail, and when famine arrives. In Egypt, the entire calendar was built around predicting the Nile's flood cycle. Miss it, and a nation starves. The problem is that weather is chaotic. Small, invisible changes in the atmosphere can cascade into completely different outcomes days later. Scientists later gave this idea a name, the butterfly effect, but the challenge itself is ancient. No civilization has ever observed every variable shaping the weather in real time. Not then, not now. So the real question was never, how do we understand the atmosphere completely? It was narrower and far more useful. How do you make a reliable prediction about a system you can never fully see? That question would shape one of the strangest, longest-running experiments in human history. In ancient Babylon, priests and scholars faced this exact problem, and they solved it without any concept of atmospheric physics. They didn't understand why storms formed or why rivers flooded. So they stopped trying to explain the weather and started tracking it instead. Every night, for generations, Babylonian astronomers recorded what they saw in the sky, the position of the moon, the movement of planets, unusual celestial events. They compared these records against what happened afterward on the ground: floods, droughts, wars, harvests. Over time, this became a massive written archive known as the Enuma Enlil, a collection of celestial omens compiled over roughly 700 years. That's longer than most modern nations have existed, devoted entirely to one task: watching the sky and writing down what came next. The logic behind this system wasn't causal. It was correlational. If the sky looked a certain way before and a flood followed, then a similar sky might mean a similar flood was coming again. No priest needed to know why. They only needed the pattern to hold. This required something just as important as observation: continuity. A single astronomer's lifetime wasn't enough to build a reliable pattern. The knowledge had to survive death, succession, and political upheaval. So the Babylonians built an institution around it. Trained scribes copied and preserved the records. Temple hierarchies passed the responsibility down across generations. Prediction wasn't treated as personal insight. It was treated as state infrastructure, maintained the same way a modern government might maintain a power grid. This is what made the system work. Not genius, not scientific theory, but discipline sustained across centuries. Individual observations are noisy. A single unusual sky might mean nothing at all, but a pattern repeated across 700 years starts to look like reliable information, even without a single equation behind it. It's worth being honest about the limits here. Babylonian celestial omens were tangled up with religion and royal authority. A prediction wasn't just meteorological. It was often read as a message about the king's legitimacy. There was no controlled testing, no falsifiable benchmark, no way to separate a real pattern from coincidence. By modern standards, this wasn't science. But structurally, it was doing something modern forecasting still depends on: turning a long, unbroken record of the past into a guess about the future. 25 centuries later, a very different kind of system would take the same basic approach and remove the priests, the temples, and the gods entirely. For most of the 20th century, weather forecasting worked in a completely different way than Babylon's. Starting in the 1950s, meteorologists began using numerical weather prediction, literally simulating the physics of the atmosphere with mathematical equations, run on some of the most powerful supercomputers on Earth. This approach, developed and refined by institutions like the European Center for Medium-Range Weather Forecasts, treats weather as a physical system that can be modeled from first principles. Feed in the current state of the atmosphere, run the equations forward, and you get a forecast grounded in actual physics. This was a real breakthrough, but it was also expensive, slow, and required enormous computing power just to simulate a few days ahead. Then, in 2023, a very different approach was published in the journal Science. Google DeepMind introduced a system called GraphCast, an artificial intelligence model trained not on the equations of physics, but on decades of historical weather data. Instead of simulating the atmosphere from scratch, GraphCast learned to recognize patterns in what the weather had done before and use those patterns to predict what it would do next. It could generate a 10-day global forecast in under a minute on a single machine at accuracy that matched or exceeded traditional physics-based models on many measures. Notice what that means. GraphCast doesn't need to understand why a storm forms any more than a Babylonian priest did. It isn't reasoning through atmospheric physics. It is finding statistical patterns across an enormous archive of past weather and betting that the future will rhyme with it. The training data itself, records like the ECMWF's ERA5 dataset, which spans decades of global atmospheric observations, plays the same functional role that the Enuma Enlil tablets once did. Not a single record, but the accumulated weight of a very long archive. The institutions behind this system also mirror something old. No individual scientist could build GraphCast alone. It required organizations capable of collecting and storing decades of consistent global data, maintaining that data across changes in staff, funding, and technology, and continuing the project long enough for patterns to emerge. Modern forecasting agencies function, in this narrow sense, the way Babylonian temples once did, as institutions built specifically to outlast any one person's involvement, because the prediction only works if the record-keeping never stops. There is an important difference, though, and it matters. Most real-world forecasting systems today don't rely on AI alone. They blend AI pattern recognition with the older physics-based models, using each to check and improve the other. Babylon never had that second, causal system running alongside its omens. It only had the pattern, which raises a strange question. Two systems, separated by 25 centuries, both left causation behind and reached for the same basic tool, a long memory, and the assumption that the future tends to resemble the past. Is that a coincidence, or something closer to a default setting in how humans and institutions handle uncertainty? Strip away the tablets and the supercomputers, and both systems are built on the same basic bet. Neither Babylonian astronomers nor modern AI models fully understand the atmosphere. Both work by assuming the future will statistically resemble the past. No causal theory required, just enough historical data and a way to check new observations against it. That's the core mechanism underneath both systems. Prediction without complete understanding. The similarities go deeper than that starting assumption. Both systems are, fundamentally, pattern-matching engines rather than causal reasoning engines. A Babylonian priest didn't need to know why a certain sky preceded a flood, only that it often did. GraphCast doesn't need to know why a pressure system forms a storm, only that similar atmospheric patterns have historically led to similar outcomes. Both also depended on long, unbroken datasets, centuries of nightly sky observations in one case, decades of global atmospheric records like ERA5 in the other. And both required institutions capable of outlasting individual humans. A single scribe or a single scientist couldn't build either system. It took temples and training schools in one era, and research agencies and international data-sharing partnerships in the other, all organized around a single goal. Don't let the record-keeping stop. Finally, both systems made the same trade. They gave up explainability in exchange for function. Neither can fully justify its predictions in causal terms, and neither needed to, as long as the predictions kept working. But the comparison breaks down in ways that matter, and it's worth being precise about where. The first difference is speed of correction. When a Babylonian prediction failed, there was no fast feedback loop. Errors might go unexamined for a generation, buried in a much larger archive of records that were treated as sacred rather than provisional. Modern AI models, by contrast, are retrained and tested constantly, with performance measured in days or weeks against fresh data. The second difference is what runs alongside the pattern matching. Babylon had nothing to check its omens against except more omens. Modern forecasting blends AI predictions with physics-based models built from real atmospheric science, and each one is used to catch the other's errors. Babylon never had that second, independent system watching its back. The third difference is validation. Modern forecasts are benchmarked against measurable, falsifiable accuracy scores. You can say precisely how often a model was right. Babylonian omens had no such test. A mist flood could be explained away, blamed on an unclear sign, or folded into the next omen without ever being counted as a failure. And the fourth difference is what the prediction was actually for. Babylonian sky reading was entangled with royal legitimacy and religious authority. A bad omen wasn't just weather news. It could be read as a judgment on the king himself. Modern forecasting, whatever its institutional politics, is at least structurally separated from that kind of authority. Its accuracy is not tied to anyone's claim to divine right to rule. These differences matter, and they're the reason it would be wrong to say the Babylonians secretly invented artificial intelligence. What they invented was something narrower and, in its own way, just as significant. A working method for producing reliable enough predictions from incomplete information, sustained by institutions built to outlive their founders. That method turns out to be far bigger than weather. Long before germ theory, physicians tracked symptoms and outcomes without understanding disease mechanisms, and made treatment decisions based on patterns alone. Long before modern economic modeling, traders and institutions tracked market patterns and adjusted behavior without a causal theory of what was driving prices. Sailors navigated by remembering currents and star patterns long before anyone understood ocean systems or orbital mechanics. Weather prediction isn't a strange exception in human history. It's simply the oldest, clearest example of a much more general strategy. When a system is too complex to fully explain, humans don't wait for understanding. They build a long memory instead, and an institution to protect it. That points to something worth sitting with. Reliable prediction has never required complete understanding. It has required disciplined, sustained observation, and a mechanism for testing patterns against reality over time. This is, in one sense, reassuring. Civilizations have acted wisely under uncertainty for thousands of years without needing to fully solve the systems they were navigating. But it carries a quieter warning too. A pattern-based system can fail silently the moment reality shifts in a way its history never captured. It happened to Babylonian astronomers facing an unprecedented drought their records had no equivalent for. And it's a live risk for modern forecasting systems now facing a climate that is changing faster than their historical training data was built to anticipate. So here's the uncomfortable thought to sit with. Every prediction system you trust today, your weather app, your news feed's recommendations, even certain medical diagnoses, is running on the same basic move as a Babylonian priest reading the sky. Pattern over understanding. Correlation over causation. That's not a flaw. It's often the only option we have. But it also means every one of those systems can be wrong in ways nobody sees coming, because the pattern held, right up until it didn't. So here's what I'm curious about. Where else in your life are you trusting a prediction from an app, an expert, or even your own gut, without actually understanding why it works? Drop it in the comments. I want to see what patterns we're all quietly relying on.